Hi students, I am Professor Awais Ahmed Hussaini, working as Assistant Professor in Mechanical Engineering Department at Sharad Institute of Technology, College of Engineering, Yadgaon. In last video, we already discussed various types of the jet condenser. In that, we discussed parallel flow, counter flow, barometric type and ejector type jet condenser. Now in this video we will discuss various types as well as construction and working of surface condenser. So let us start with the classification. We already covered these 4 types of the jet condenser. Now we will discuss surface condenser. The another name of the surface condenser is non-mixing type condenser. There is no mixing of steam as well as water, so the name is given non-mixing type condenser. There are 4 types: downflow surface condenser, central flow surface condenser, regenerative type surface condenser, and last one evaporative type surface condenser. So here you will get idea about various elements and components of the surface condenser. So basically it consists of one cylindrical shell made by corrosion resistance material, and n number of the welding techniques, advanced welding techniques are used for joining. It consists of the tubes. These are fitted with the plates. There are 2 water boxes are there. On left side there is one water box, and on right side also there is another water box is there. Baffle plate is provided for restriction of the 2 fluids. It avoid the mixing of the 2 fluids, so that's why that baffle plate is used. So here there is the inlet and outlet portion of the cooling water as well as inlet and outlet portion for the steam. So here you will get idea: cooling water inlet, this is a warm water moves out, steam from the turbine or boiler is enters from the top side, and finally we will get the condensate and it enters in the hot well with the help of extraction pump. Similar way, the air extraction pump is needed. The main function of the air extraction pump is to remove the moisture or remove the air which is trapped in the container or that particular vessel. If some air remains in that particular area of the shell, so that it affects on the performance of the condenser efficiency, and vacuum efficiency goes on reduces. In order to improve the vacuum as well as condenser efficiency and to maintain the proper vacuum inside the shell, we must have to use air extraction pump. So the main function of the air extraction pump is to remove the air which is available in the condenser shell. Also another extraction pump is needed here. The name of that pump is condensate extraction pump. The main function or main purpose of that condensate extraction pump is to extract the condensate in the hot well before entering into the boiler. So here it consists of the n number of the tubes through which the water is continuously circulated and the steam is continuously blowing over the tubes. So this is all about the construction of surface condenser. Now we will discuss the working. So here the cooling water from the cooling tower is continuously moves through this particular passage. The name of that passage is cooling water inlet. Then it passes through the tubes, and finally this continuously moves through the tube section, and it moves through this particular passage, and at the end that warm water leaves out. Again that warm water enters in that cooling tower for cooling purpose, and the same water is continuously repeats itself. So here the main difference between jet and surface condenser is that particular water is continuously circulated in the passage of the shell, but it not happen in case of that jet condenser. So this is the main difference between jet and surface condenser. The meaning is that condensate is continuously circulated, it is continuously reused, but it is not reused in case of the jet condenser. Also the main difference between jet as well as surface condenser is In jet condenser there is a mixing of two fluids, that is steam as well as water, and phase change takes place. But here in case of the surface condenser there is no any mixing of two fluids, that is steam as well as water, and simultaneously the steam from the turbine or from the boiler is enters from the top side and it is continuously blowing on the surface of the tubes. So due to that the heat transfer takes place because of conduction as well as convection, and at the end we will get the phase change because of latent heat of the condensation process, and heat is rejected, and finally we will get condensate, and that condensate, that is water, is entered in the hot well through the condensate extraction pump, and the same condensate is going to boiler through the boiler feed pump. So this is a construction as well as working of the surface condenser. Now the first type of the surface condenser is downflow surface condenser. So here the exhaust steam enters the top of the condenser shell. So from here the steam from the turbine or boiler is continuously moves and it continuously blows on the tubes. So these are the tubes, n number of the tubes. The steam is continuously blowing on the tube surface, and inside that tube the water is continuously circulated. So the exhaust steam enters the top of the condenser shell and flows downward over the water tubes. The water tubes are the double pass. The cold water flows in the lower side first and then upper side in the reverse direction as that of such kind of the things. The same cross section is mentioned here. It is the same as that of this particular surface condenser. So this is only side view. So the name is given downflow surface condenser because the location of the air extraction pump is at the bottom side or at the down side. So the name is given downflow surface condenser. The main purpose of that air extraction pump is to extract the air which is available in the portion of the shell in order to maintain the proper vacuum in the condenser shell. If some air remains in the condenser shell, it affects the performance on that particular condenser, and ultimately that condenser efficiency as well as vacuum efficiency goes on reduces. So here one baffle is provided. The main purpose of the baffle, here also you will get idea about that baffle. The main function of the or main intention of that baffle is to separate two different fluids, that is steam as well as water. Now here whatever the condensate is collected at the bottom section, it get extracted in the hot well through the condensate extraction pump. So the main function of that condensate extraction pump, generally centrifugal or the gear pump, is used to extract the condensate in the hot well. So this is all about downflow surface condenser. The main speciality or the name is given downflow because the condensate is collected at the bottom side as well as the location of the air extraction pump is at bottom side. So the name is given downflow surface condenser. So here the second type is central flow surface condenser. In central flow surface condenser the working is same as that of the downflow surface condenser, only difference is in the location of the air extraction pump. In downflow surface condenser, the air extraction pump is located at the bottom or at the down position of that shell. But in case of the central flow surface condenser, the air extraction pump is available at the central position. So here you will get idea. So this is the air extraction pump which is available exactly at the center of the shell. So here the cross section of this particular design is here. So here also the steam is continuously flowing through the top side from the boiler or turbine area, and it's blowing on the surface of the tubes. Through that tubes the cooling water is continuously moving. So at the end, at bottom portion, you will get that condensate, and that condensate is collected in the hot well through the condensate extraction pump. So here there are totally two pumps are used. First is that air extraction pump, and the main speciality of the central flow surface condenser is the air extraction pump is exactly available at the center of the shell, generally dry as well as wet pump is used. The name of that pump is Edward air pump. It is a piston type of the pump. It work same as that of that engine type. Working is similar with the engine working, that is upstroke and downward stroke compression and all. And main purpose is to extract the air which is available in the condenser shell in order to maintain the proper vacuum. Similar way, the main function of that extraction pump is to extract the condensate which is available at the lower section of the shell and enters into hot well. So this is the shell area on the side portion. So this is central flow surface condenser. The main speciality of the surface condenser is there is no any kind of the mixing of two different fluid takes place. Like steam is never come in contact with the water in surface condenser. The water is continuously flowing through the tube and steam is continuously blowing over them, and phase change takes place because of conduction as well as convection effect, and latent heat is produced, and because of that the phase change from the vapor or the steam is get converted into liquid, and that liquid is nothing but that condensate. Now the next important type of the surface condenser is evaporative type surface condenser. Here you will get idea about that evaporative condenser. The main speciality of that evaporative condenser is there is no any need of separate cooling tower. So here that cooling tower and condenser become a single common unit. But in case of the other previous two types, that is central flow as well as downflow, there is a separate provision of that cooling tower, but it is not happen in case of the evaporative type condenser. So here you will get idea about the different parts. The evaporative or that evaporation of some cooling tower that particular provide the cooling effect, thereby steam condenses. The steam to be condensed is passed through the grilled tube and cooling water is spread over the outer surface of the tubes. The evaporative condensers are mostly suitable for small plants. Mostly it is implemented in case of the textile industries, some food preservation industries, some cold storage, as well as in case of that sometimes milk processing industry or in sugar factory as well. But in case of the large capacity or medium capacity thermal power plant, the jet condenser are used. So here you will get idea about the section or elements of that evaporative type condenser. Here you will get a cooling water pond where cooling water is continuously available. The name is given, that is sump is nothing but the storage. Now that water get cooled because of the natural force, natural air. So cold air is continuously flowing through this particular area for cooling purpose, for heat transfer purpose. So this particular pump is required to bring that particular cooling water and allow it into the condenser area. So this is the fan. Fan is provided optionally. If we want that forced or induced effect, then that fans are used, and in absence of that fan and that particular blower, there is a natural type evaporative condenser is also available in different industries like cold storage and milk power plant, or in case of the milk unit, milk processing unit, or steam small capacity steam power plant like sugar factory as well. So here the construction and working is very simple. So it consists of the n number of the tubes. Through that tubes the steam is continuously flowing, and at the end we will get condensate. So this is steam in section, and at the end we will get condensate. So the main working is whatever the water is pushed up from this particular pump, it continuously moves or it continuously showered over the tubes through that particular grill arrangement. So perforated trays is there, and through that perforated holes the water is continuously passes over the tubes, and when that steam which is available inside that tube come in contact with that water, then latent heat of the condensation takes place, heat transfer takes place because of the convection as well as because of conduction, and phase change from the vapor to liquid takes place, and at the end we will get condensate. To improve the performance, that forced type, that is fans, are used to extract that air, moist air which is generated during that phase change process or heat exchange process. So this is all about evaporative type condenser. Now this is the advantages and disadvantages of surface condenser. The advantages are: the surface condenser is used for the large capacity plant. Mostly out of these last three types, that particular downflow and central flow condenser is mostly used for large capacity power plant, that is NTPC, National Thermal Power Corporation power plant, where the pressure generation is more than 100 bar or 80 bar. But that evaporative condenser is mostly used for small application like cold storage, milk processing unit, ice factories and all. Then second one is the high vacuum can be created, so it is good. So vacuum efficiency of the surface condenser is better as compared with the jet. Condensate is free from the impurities, but it did not happen in case of the jet. So that condensate is not used again and again in case of the jet, but that condensate is continuously reused as a feed water to the boiler in case of that surface condenser. Impure water can also be used as a cooling medium. Air leakage is comparatively less, hence less power is required to operate air pump. This is the most important thing, that more power is required in jet type condenser. Few are disadvantages as well. The first is design is complicated and costly, high maintenance cost, occupies more space and require more circulating water. So these are the disadvantages of the surface condenser. Now we will discuss the difference between jet condenser as well as surface condenser. So here there is one main difference is direct contact of the two fluid, that is steam as well as water. But here in case of the surface condenser, there is no any kind of the contact between that steam and water, and phase change takes place from that steam or vapor to liquid in both situations. So here you can see it as a direct contact type, it is a non-contact type. So condensation due to mixing and condensation due to heat transfer by conduction as well as convection. So this is the main thing in case of the surface condenser. This is the main speciality. Now as far as that maintenance point is to be considered, the maintenance cost is low and the maintenance cost is high in case of the surface condenser. Less vacuum is created, so less vacuum efficiency as well. More vacuum is created, more vacuum efficiency here. Small floor space is required, less space is required. It required large space because of that tube and plate arrangement, and cooling water, that capacity is also large in case of the surface condenser because it is mostly used for the large capacity power stations. Now condensate cannot be directly used as a feed water, so it never be reused again and again. But that condensate is recycled or reused again and again as a condensate in the cycle. So this is the main speciality of the surface condenser. Less power for pumping, more power for pumping is required. Less quantity of the cooling water is required, large quantity of the cooling water is required here. So this is suitable for the low capacity plant, and definitely it is suitable for the large capacity of plants. So students, in this video we have discussed various types of the surface condenser. First we discussed downflow, second central flow surface condenser, and third we discuss that evaporative type surface condenser, and at the end we will discuss advantages, disadvantages and difference between jet condenser and surface condenser. So students, our next video will be on cooling tower and their types along with their construction and working. Thank you.